myself, Janil Popat. I welcome you all. Let us discuss consolidation today. Consolidation is a natural process. Consolidation happens by the time, but by natural loading, or we can say static loading. Let us discuss technical sides of consolidation. For fully saturated soils, compression of soil happens due to expulsion of water from voids due to or under static pressure. It is called consolidation. We can see by these phase diagrams consolidation. Let us understand that here two phase diagram of a soil particle is shown. Now this red area is showing solid particles and white area is showing water particles. Now under static pressure, under natural static pressure, the soil particle will compress, and due to that compression water particles will go out from this, and due to expulsion of water soil particle volume will decrease, and this process is known as consolidation. Let us move forward and understand stages of consolidation like initial, primary and secondary stages. When partially saturated soil mass gets under external loading, it gets compressed and decrease in volume is seen due to expulsion of air particles and compression of solid particles. This small decrease in volume of soil mass is known as immediate settlement or initial consolidation. Let us understand primary consolidation. So, after initial consolidation or immediate settlement, further reduction of volume of soil mass is due to or known as primary consolidation. And secondary consolidation, the reduction in volume of soil mass continues at a slower rate, and furthermore after expulsion of air voids or after primary consolidation, further decrease in volume of soil mass is known as secondary consolidation or creep settlement. Let us move forward. Spring analogy. The process of primary consolidation can be understood by spring analogy. Let us see that. In this figure, we can see a piston and a spring hanging on a cylinder full of water. It basically represents soil water system. In the first case, here piston and a spring is kept here, and valve is opened and water is filled in this cylinder. Then external load is applied to the piston so that the spring and water is under pressure. Now let us assume we have applied 10 units of pressure. So in the first case, the whole 10 units pressure will be taken by spring only and by not water, because valve is opened. After this we will close the valve as the water is filled, and we can see here there is no pressure on water. Let us move forward. If we increase the pressure on a piston, like if we have applied 10 units before, we will increase 5 units more, as total load, total external pressure is of 15 units. Now valve is closed so that the external 5 units will be taken by water as the valve is closed. We can see here pressure in water is increased as it is 5 units. We know this equation as total stress is equal to effective stress plus neutral stress. Now neutral stress or pore water pressure is here increased due to closing of the valve. So there is 5 units borne by water and 10 units by spring. If we open the valve partially and then close it, some water will get out from here and some pressure will be released from water. So now we can see that total 15 units of pressure is there. Before it was 10 units. Now on spring there is some increment in pressure, that is delta sigma dash. So some delta effective stress is increased in this spring and somewhat pressure, that is delta sigma dash only, that is decreased from water because the water got out. We can see here in the second stage there was some higher water pressure and in third stage there is lower pressure of water. Let us move forward. If we open the valve more and then close it, we can see that some more water will be out of that and now total external pressure is taken by spring only. Now U is equal to 0 here. So total stress is taken by effective stress and we can say that total stress is taken by spring, not by water. Here we can see water pressure looks 0. So spring analogy can be understood for primary consolidation of a soil water system. Here spring means solid particles, where valve means permeability of soil and water means voids and water in the voids. So that's it for spring analogy. Let us move forward to void ratio and effective stress relation. Consolidation test is performed through the device consolidometer. Now, if a remolded clay specimen is tested in a consolidometer, their results can show the relationship between void ratio and effective stress. This graph will help us to understand the relationship between void ratio and effective stress. Here AB curve, you can see the curve AB. AB curve represents a remolded clay specimen is given some pressure and the pressure up to which extent, up to the extent at which it is not given pressure before that time. I mean, we can understand that if the AB curve is the result, then the pressure must be given up to highest extent up to that time. So AB curve is known as virgin compression curve. Now if the loading is stopped, then the graph will move like this, B to point C. The void ratio will move from B to C. It will not gain its original position due to some permanent changes in the soil structure. Here BC curve is known as expansion curve and CD. Let us move further. If I give further loading, then from point C graph will go to D. Now CD is known as recompression as we are giving compression again. Now point B and point D can be differentiated as on same effective pressure there is a difference in void ratio. So it will not get original void ratio by giving recompression. Further giving load, we can get DE curve. DE is also a virgin curve. Now if this curve is plotted on semi-rhythmic plot or semi-rhythmic graph, it can be seen like this. Here we can see line AB, line CB are got straight. So Tarzaghi has given some empirical formulas from this straight line, curves and their slopes. Compression index. Tarzaghi has given E is equal to E0 minus Cc into log 10 base sigma dash upon sigma dash 0. Here E is void ratio, E0 that is initial void ratio in starting. Cc means compression index, log 10 base sigma dash sigma 0 dash. Here sigma dash is final effective pressure and sigma 0 dash that is initial effective pressure. And from that we can write Cc as E0 minus E upon log 10 base sigma dash upon sigma 0 dash. That is how Cc compression index is denoted. Now Cc compression index value can be get from slope of line AB, of slope of straight line AB in this figure. Let us move further. Another empirical formula given by Terzaghi, that is for swelling index. E is equal to E0 minus Cs into log 10 base sigma dash upon sigma 0 dash. Here Cs is the new thing. Cs is swelling index. Now swelling index can be obtained from the curve BC. Slope of the curve line BC, that is expansion curve, is denoted as swelling index Cs. Cs can be written as E0 minus E upon log 10 base sigma dash upon sigma 0 dash. Let us move further. This graph is showing general behavior of soil, is showing that as the effective stress is increasing, void ratio of that soil is decreasing. Now Terzaghi has defined some more empirical formulas like coefficient of compressibility. Now as compressibility coefficient is defined as change in void ratio per change in effective stress, where it is denoted as AB. Coefficient of compressibility is denoted by AB and is equal to written as minus delta E upon delta sigma dash. Here it is written as negative. Why negative? We should be having question like this, but it is shown as negative sign due to the graph. Whenever effective stress will increase, the graph will go down, void ratio will decrease. That is why minus signature, minus sign is shown. Here delta E can be written as E0 minus E. E0 is initial void ratio and E is final void ratio by delta sigma dash. Now sigma dash minus sigma 0 dash. Now sigma dash, that is final effective pressure, sigma 0 dash, that is initial effective pressure. Another coefficient of volume change is defined. Coefficient of volume change is defined as change in volume per initial volume. It also can be written as delta V upon V0. Empirical formula for that, that is MV. It is denoted by MV, and formula for MV is minus delta E upon 1 plus E0 into 1 by delta sigma dash. It can be also written as delta V by V0 is equal to delta E upon 1 plus E0. Now, if the soil is confined, from all sides, so after compression there is only one dimension in which it can compress. So we can also write delta V by V0 as delta H by H0, that is thickness of the soil or height of the soil, is equal to delta E, or we can write E0 minus E upon 1 plus E0. Now we already know coefficient of compressibility, that is AB is equal to minus delta E upon delta sigma dash. So substituting this as AB here, MV can be AB upon 1 plus E0. Also MV can be written as minus delta H upon H0 into 1 upon delta sigma dash. It is nothing but in place of minus delta E upon 1 plus E0 we have put minus delta H upon H0. Furthermore, degree of consolidation is also defined. Here E0, that is void ratio initial, where ET is showing void ratio at time t, and EF, that is void ratio final. So these are the formulas which will be useful for numericals also. Let us move forward to pre-consolidation pressure. Pre-consolidation pressure is nothing but a temporary overburden to a soil which has been subjected to an external load and under which it is consolidated. Now, pre-consolidation pressure is very important to obtain. For obtaining or determining pre-consolidation pressure, Casagrande has given an empirical theory. Through this graph, we can determine pre-consolidation pressure. This graph is between void ratio and effective pressure sigma dash. This graph is obtained from a consolidometer test for consolidation of an undisturbed clay sample, and it is plotted on semi-logarithmic graph. In this graph, let us understand the procedure to determine pre-consolidation pressure. First of all, we have to decide a maximum curvature point A according to our eye judgment. So I am deciding this as a point A. Next step is to draw a horizontal line from point A, that is line AB. AB is drawn. Then I will draw a tangent AC to the curve at point A. Here AC is drawn, AB is drawn before. Then I will do, that is, bisect line AB and line AC. So horizontal line and tangent will be bisected by line AD. The bisector will be given name AD. Then this curve A will be extended to a straight line to meet the bisector AD at point P. So I will obtain the point P, and the effective pressure sigma dash at point P, that is sigma P dash, that is our pre-consolidation pressure. So this is the method to determine pre-consolidation pressure. This is empirical method. So let us keep our session up to here. We will learn consolidation more in next video. Thank you.